All right, this is the second part of the notes for H6-7, solving exponential and logarithmic equations. We already worked on the part here where we were evaluating logarithmic expressions, finding their values by using the different properties. Now we're going to look at just solving a variety of equations. So the first ones we're going to look at here, the directions state, solve each equation. Give solution in calculation ready form and then use a calculator to find the answer to the nearest thousandths place. So the first one here, example 1, solve 2 times 4 to the power of x minus 18 equals 82. So this one is an exponential equation. And you need to pay attention to what kind of equations you're dealing with here. We know this is exponential because it's got an x in the exponent. Another thing you want to ask yourself, are there any logs right now? And there are no logs in this equation. So what we want to try to do when we have an equation like this is we want to get it to the form where it's the base raised to a power or an exponent and that equals a value. So in order to get it to that form, we're going to need to undo part of the equation or get rid of the 18. So we have 2 times 4 to the power of x equals 100. Then we're going to divide by 2 on each side. So we now have 4 to the power of x equals 50. Now we've solved a lot of these already right now in the past couple days. We're going to take it and we're going to do the log of each side there. And you can do whatever base you want. I'm just going to do log base 10. So I have log of 4x equals the log of 50. We'll use our power property here, move our x out in front, so we have x times the log of 4 equals the log of 50. And then when we divide each side by the log of 4, we're going to end up with x equals log of 50 divided by the log of 4. This right here is what we would consider to be our calculation ready form here. So this is our calculation ready form. We can then take that here and put it into the calculator to get what our decimal approximation would be. And when we do that with this problem here, we should end up with, I think, approximately 2.822. You can always take that value, plug it back into the equation for x, simplify it there, and it should be pretty close to true. Remember, when you round the value here, it's going to change your answer just a little bit. Okay, so example 2 now. Example 2, same type of equation. Maybe you want to pause the video, try to work this one out, and then you can check your answer afterward. I'll go ahead and start working through it there. That way, if you need to look back at an explanation, you will have one. Okay, so this one's already in that form of a base raised to a power equals a value there. So what we want to do here is go ahead and start off with taking the log of each side there. So I'm going to say the log of 3 to the power of 2x minus 1 equals the log of 5. And now we can take our exponent and move it out in front. When we do that, though, we want to make sure that we keep it all together. So I would put it in parentheses, 2x minus 1, or that quantity times the log of 3. And that's going to equal log of 5 still. You're going to do the exact same thing you've done before. Divide each side by log of 3. So what we have now is 2x minus 1 should equal log of 5 divided by log of 3. But we still need to solve for x, so we got to get x by itself. So we're going to need to add 1 and then divide by 2. So 2x should equal the log of 5 over the log of 3, and then plus 1. And then we'll divide that whole thing by 2 to get our answer. So our calculation ready form would be the log of 5 divided by the log of 3 plus 1, and then that entire expression is going to be divided by 2. So that's like our calculation ready form. But when we take it there and we go ahead and come up with the decimal approximation, I believe it is 1.232 if I rounded correctly. I'm going from memory there, so if it's off, just let me know in class, we'll fix it. Okay, let's move on. Next one, slide E, says logs on both sides of the equation. Now we did a little bit of these in previous notes. This is where we've got a log, at least one log on each side. Now I said you need to start paying attention to the details that the equations are giving you. If you have logs on both sides here, okay, a lot of times they're a little bit easier because we can get it down to single logs and drop the logs. But we got to make sure we do that first. So there's multiple logs on one side. Let's use our properties to simplify it down to one log. Since we have 3 times the log base 5 of 2 plus log base 5 of 7, let's go ahead here. If we move that 3 up here, it's like a 2 cubed. And then if we simplify that, right now it's going to be log base 5 of 2 cubed would be 8 plus log base 5 of 7. Let's use the product property here. That's going to turn this into log base 5 of 56. And that still equals log base 5 of x. If you take a good look at that equation, the only thing that's missing here is the value of x that would make it true. Well, in order for it to be true, that x is going to have to be 56. And that would be our answer. In terms of checking it, I'm not going to waste time checking it right now on the video because I know that these videos can get long. So you can plug it back in to check it to make sure it all works. I'm going to tell you for the notes' sake, it does. Now let's look at example 2. This might be an opportunity for you to pause it, work through it, and see if you get the correct answer. Okay, the answer I'm going to give to you is x should equal 54. Okay, that's the final answer on that one. If you need help going through it there, just remember this is an exponent. You're going to have to move it up here. That would be log base a of 9 to the 3/2 power. Okay, and then we saw that plus log base a of 2. Well, 9 to the 3/2 power is going to be 27. So that's log base a of 27 plus log base a of 2. Use your product property there, and we now have log base a of 54 equals our log base a of x. Therefore, x has to equal 54. I wasn't planning on explaining that one, but I guess I did it anyway. All right, let's move on to the next type. For this one, you'll notice you have multiple logs on one side, but you only have logs on one side, so that introduces a different approach for solving this equation. So the first thing we need to do is the same as the others. We've got multiple logs on the same side of the equation. We need to use those properties to combine those. This will become log base 7, and we're going to take this and we want to multiply, our x plus 1 times our x minus 5. So when we do that, that's going to be log base 7 of x squared minus 4x minus 5. That equals 1. So when we have an equation, we have a log on just one side. See? So this is just on one side of the equation that we have a log. This is where we need to take it and we need to put it into our exponential form. We'll take our base is 7, the exponent is 1, and that should equal our value. Rewrite this. This is 7 to the first power equals x squared minus 4x minus 5. Now it's just a quadratic. Let's subtract 7 from each side. We have 0 equals x squared minus 4x minus 12. That factors into x minus 6 times x plus 2. Still equals 0. Use our zero product property, and we'll end up with x equals 6 and x equals negative 2. Now this is where we need to make sure that we are checking. Let's look at x equals 6 first. If we take our 6 and we plug it in, we have log base 7 of 6 plus 1 plus log base 7 of 6 minus 5. That should equal 1. This would simplify to log base 7 of 7 plus log base 7 of 1 equals 1. Log base 7 of 7 we know equals 1 plus. Now if we took log base 7 of 1 and we set it equal to x and then we rewrote it in its exponential form, you'll see that this is 7 to the power of x equals 1. So you know then that the power of x here that we would have to be 0, because 7 to the power of 0 equals 1. So this means 1 plus 0 should equal 1. Well, that makes a true statement, just like any other equation that you would solve. So x equals 6 is an answer. But when we try to plug in our negative 2, let's see what happens. Log base 7 of negative 2 plus 1 plus log base 7 of negative 2 minus 5 equals 1. Now when you do log base 7 of negative 1 plus log base 7 of negative 7 equals 1, we run into a problem. Think about this expression. Log base 7 of negative 1. If we set that equal to x and we go through it here, that would be saying 7 to the power of x equals negative 1. Well, there is no value that we could plug in for x, or we're going to multiply 7 times itself or divide it by itself to be able to get a negative number. So you will never ever be able to have negative numbers in here for your values. Okay, so in this case here, this is an extraneous solution, and our only answer is x equals 6. If you have questions about that, mark that. We can talk about it. Here's one down here that you may try. It's a very similar problem. If you have questions, you can bring them to class. I'll go ahead and work this one out real quick just so that they are all done. So log base 3 of x plus log base 3 of the quantity x minus 6 equals 3. When we rewrite it, we have log base 3 of x squared minus 6x. That equals 3. So remember, we've got one log on one side. So this means we need to convert to exponential form. So we've got here 3 to the third power equals x squared minus 6x. This is going to be 27. We'll set it equal to 0. We'll factor it. And then we'll apply the zero product property to get that x equals 9 or x equals negative 3. When we check it, right, if we plug in our 9 here, we've got log base 3 of 9 plus log base 3 of 9 minus 6 should equal 3. Well, log base 3 of 9, 3 to the second power equals 9. So this is the same thing as 2. This would be the same thing as log base 3 of 3, which would equal 1. And 2 plus 1 is 3. So we know that one works. Negative 3, on the other hand, we can tell already that it's not going to work because when we plug in log base 3 of negative 3, that's going to shut us down already there. Therefore, that is extraneous. And our answer would be x equals 9. If you have questions about these, please make sure you mark them down, bring them to class, and we'll talk about it then. Thanks for watching.